All right. I hope everybody can hear me. I'm giving some chance for everybody to get back in. I believe this is the last time we'll have to do that for today.
Back, well, last week I had to do it about 4 times.
Yeah.
Right.
Yeah. We will sort this out so that we won't have to deal with it again. We will sort it out for once and for all. Okay. All right. So let me go back to presentation. I want to end by 11:30, which is about 10 minutes. What I would advise you to do is, since we are on lockdown, and I'm assuming that you have some more time. I know that some places have to go to work, but I'm assuming that you have a bit more time. If you have not gone through the videos or the content on the site, I would advise you to make an effort to go through it today. Okay, and any questions that you may have, you can post them in the discussion forum, or you can ask them in the WhatsApp group. Okay, our WhatsApp group was a bit quiet this week. But please make use of these two instruments that have made this thing available to us. Okay, so I wanted to highlight disinfection and flushing. Okay, there are a few things that were mentioned there that I'm not certain of whether you were very familiar with some of the terms and some of the things that will be discussed at this point. But it gives specific requirements, because what happens after or in the process of installing the pipe, we want to make sure that we disinfect that pipe as well. And there are several ways that we can do that. There are several things that we are looking for in terms of disinfection. Okay. One of the things that we have to do the pipe is to flush it. Depends on where you are installing the pipe. You may have debris, soil, or particles that inadvertently end up inside of the pipe. So before we return it into operation, we want to make sure we flush out these things. And we are given guidelines. We are given guidelines for flushing. So we want to remove any debris or mud left after installation, or shoes. All right. And we will usually use hydrants. Okay. Hydrants should be used for flushing at a minimum velocity. Okay. We look at how fast the water is flowing. Okay. Velocity. Okay. Of 2.5 feet per second. Okay. Now, velocity, I just want to point out that velocity and flow are two different things. Okay. Velocity is measured in distance per time. So what distance can I move in what period of time? Whereas flow is measured in volume per time. How much volume can I transport through the pipe for a specific period of time? And I want you to make sure you know this distinction. Some persons tend to mix up these two, velocity and flow. Okay, so flow is looking at volume moved in a certain period of time. Velocity is looking at distance moved in a particular period of time. So make sure you are aware of that. Okay, and we want 2.5. That's what we're looking for, 2.5 feet or 0.8 meters. That's our minimum, but we prefer 3.5. And we're looking at that velocity because we want it to be able to move through the pipe fast enough to be able to carry things with it. Okay, still together? Okay, we want it to be able to carry, for instance, carry out. It's like you have a hose. Think of this scenario. You have a hose and maybe leaves or dirt. You have it in the concrete part of your driveway and you just want to get rid of it. So in some instances, people take a power wash and they use the power wash. A power wash is a good example. They use the power wash to just push the things away. So that power wash has a certain force because of the speed at which the water or the velocity at which the water is passing out of the nozzle. It gives it a certain amount of force. Okay? And that force enables you to move debris. Okay? And that's the whole idea. You want it to be able to have that velocity, which provides the force to move the debris out of the pipe. Okay? And we're told that we want to allow 3 or 4 changes of water. Okay? Disinfection, we use either tablets or hypochlorite. Hypochlorite is the liquid or the solution. And well, a lot of times we use sodium hypochlorite for the solution, but we have it in the form of the tablet. Well, calcium hypochlorite is usually in the form of these tablets. If you looked at the video, there's one of the videos where they were showing you how they are placing these tablets on the inside of the pipe. Okay. Now, if we're using tablets, we want to make sure we maintain 25 milligrams over 25 milligrams per liter over a 24-hour period. Now, in some of the maths we did, we looked at milligrams, we looked at liters, and so on. So you should have some kind of understanding of that. So when we talk about 25 milligrams per liter, we are talking about the amount of solid in grams, in milligrams, that we have in a certain amount of water, in 1 liter of water. Usually when we make solutions especially from solids, we weigh out the amount of solid and we would put the amount of solid in a specific volume of water. It's just like when you're making certain beverages or you're doing certain things at home. In some instances you weigh or you measure with a measuring cup or you measure with tablespoons or teaspoons and so on. It's the same concept. We want a certain amount of solid in a certain amount of liquid. So in the water in the pipe, we want to maintain it at 25 milligrams per liter of free chlorine. When we talk about free chlorine, we are talking about chlorine that's in the water that has not reacted with particles, that has not reacted with contaminants, that has not reacted with microbiological agents in the water. So that's free chlorine, not just chlorine that is there in the water that is available. If it's not free, it means it's not available for disinfection. Okay, so we want to maintain that. Now, if we are flushing, we're using a flushing method, we want to maintain up to 100 milligrams, okay, solution in the water. Okay, 100 milligrams of chlorine. If we are, and our final residual, we want it to be 10 milligrams per liter after the 24-hour period. So we are disinfecting, we're flushing for 24 hours. We don't our stuff for a certain number of hours. If we are using what we call a slug dose, right, which is a slug or sludge sometimes, we're looking at a thicker kind of solution in most instances. Okay. Yeah, 50 milligrams. Depend on the, Shannon, depends on the type of disinfectant, the format in which the disinfectant is in, and the way that we are um, doing the disinfection, the concentration may change. Okay. One of the important things we want to keep in mind is the free chlorine. The shock disinfectant is similar, well, the concentration of free chlorine is similar to that in the slug dose. Because in the slug dose, we want our final free chlorine to be 50 milligrams per liter of free chlorine. But we may start at 100 milligrams per liter for 3 hours. Or if we're doing it for less than 3 hours, we may do 300 milligrams per liter for such a shorter period. Okay? But in terms of disinfection of either a new installation or repair, these are some of the things that we consider. Now, in some cases, we use what we call a swab. We dip a piece of fabric in a bucket of solution of high concentration, and we use that to swab inside of the pipe and the fittings in terms of a new installation. So that's one way that we disinfect. Okay, all right, thanks, Alphonsus. Okay, next thing I wanted to look at was, okay, now the screenshot that I have here looks at this basically a summary of some of the things in the SCADA system. Now, when we start talking about instrumentation and control, things can get very detailed, and we have a lot of information that we start looking at. Can you guys hear me? If you can hear me, just, okay, great. I just saw something about internet, so I was wondering what was going on. All right, great. So what I was saying, sometimes when we look at instrumentation and control, we start seeing a lot of detail, a lot of data, a lot of information, a lot of things that we need to know and so on. I want to try to simplify what you have to know. Okay? In a water distribution system, there are certain things that we need to keep track of. Okay? The things that we need to keep track of, we refer to them as parameter. I could call them, I could just use that word and say parameter. So some of these things are flow, water level, pressure, temperature, electricity or electrical or equipment activity. And then we have some chemical things, or we have some instruments that look at things like turbidity, pH, and some of these other elements. So all of these are parameters and parameters are things that we can measure, okay? We can measure them in some way. We can tell, for instance, what is the flow rate in this pipe? If I have a sensor, I can measure it. So we use sensors to measure parameters, okay? So these sensors are going to measure and send that information to a central control where we are monitoring these parameters. So that's essentially what's happening on the instrumentation and control. We have sensors detecting what levels these parameters are at, sending that information back to a central control, and then the central control is monitoring what information is being sent back, and then central control uses the control aspects of our system, which can be manual, automatic, or digital, to take an action. Pump that is pumping to a tank. We have controls that enable us to turn the pump on and off remotely. When we say remote, it means we are not in the same location. So the pump is several miles away, and we're sitting in an office in front of a computer. Okay, so that's what we refer to when we say remote. So we can control turning the pump on and off. We also have a sensor inside of the tank. The sensor is indicating to us the level of water in the tank. Now, we don't want two things to happen. We don't want the tank to overflow because we'll be wasting our water. And two, we don't want the tank to be drained, because if you remember some of the things we discussed when we were discussing storage, we said that storage tanks provide additional capability in our water system, including maintain pressure and flow and so on. Okay, so it's not just water we put there for us to use later, but it has other things. So we don't want the tank to be empty either. So what will happen is we will be monitoring, and sometimes if the system is automatic, it will monitor, the sensor will monitor the level of the water. When the water gets to a certain point, it will stop the pump automatically. From the tank, the water gets to a certain point, it automatically starts the pump. Now, if it's manual, it could be one of two things. It could either be me as an operator in a control room, turning the pump on when I see the level of the water get to a certain point, or asking workers who are out in the field to go turn on the pump if I don't have the capability, actuators and what have you. Now, sorry, not actuators. If I don't have things to actually turn the pump on and off remotely. Now, the same thing can happen for valves. I can have what we call actuators that enable me to to open and close the valve remotely. Okay, I can have controls for things in the treatment plant. So as I'm sensing the concentration of certain things in the water, I can have a system that will either increase or decrease the flow from the flow rate from the chlorinator. Okay, so this is what we are talking about essentially when we talk about instrumentation and control. We are talking about systems that we have in place that allow us to monitor and control various parameters or variables in the distribution system, in the water system as a whole. So that's essentially what we are looking at. This separates them into the primary ones, secondary, and into control systems. But essentially what we are doing is measuring, monitoring, controlling. That's essentially what we are doing. And all the pieces of equipment, all the systems that form part of this system enable us to do that, either manually, automatically, digitally. Okay, so that's essentially what this is talking about. Now you'll see terms like things like telemetry, multiplexing. So I encourage you to go through the content that's available on the site, because it goes into all of the detail. Now, at level 1, you may not be required to know everything about instrumentation and control. As you continue to become certified at other levels, your knowledge will be deepened in terms of instrumentation and control. I want to mention SCADA. SCADA system, which stands for Supervisory Control and Data Administration. SCADA system is a specialized system that we use in utilities, in water utilities, to help us with instrumentation and control. It's a computerized system in most instances. You will be sitting in a control room with a computer monitor in front of you, and through software, you're able to make changes in the distribution system. You're able to send commands to other aspects of the distribution system to control the water level, the flow, the pressure, to make changes to these various parameters or variables. So that's what that section after this. There are 2 videos on the site that actually deal with that in a lot of detail. I think in more detail than you need to know at this level. Okay. Yeah, acquisition is also used as administration. Yeah. Okay. So thank you, Alphonsus. So I'm not sure if Alphonsus wants to add anything else.
No, I think the class was good. I think I was getting scared that you went down in a lot of details in the SCADA.
Oh,
But,
nah.
I think it's useful, especially in those days. How useful it is. I mean, for example, we've done some projects in utility before a few years ago, 2008 in Grenada, and I mean, they spent a lot of money from European grant and loan to put in SCADA system in 3 of the most remote plants. And it's linked with Digicel, and you get when the turbidity is rising to shut down, to add more coagulant, and and so on. It works. In our case, it was married with photovoltaic cells and mounting of this, so it works.
Mm-hmm.
The only thing is that sometimes, in our case, it seems that this technology is a little above our head, and I know the operators on them and one of such plants have made the thing, instead of automatic, it's semi-automatic now. I don't know what will happen in the future. We have that tendency to go and start to what I call bastardize the thing and bring it back up. It's manual. But the systems work, and I think that's the way you go when the filtration plants I've visited in Europe and North America. I mean, one man walking around with his cell phone and a valve goes, something wrong with a valve, and time for a valve to close, and it gives you a beep on the phone, and he touch that, pull the app out on the phone, and so on, and it does it. So someday the islands will get there, I suppose.
Yeah, one of the issues I have with a lot of these systems is that very often, and it happens in various areas, you have a project that is initiated or implemented by a foreign entity, and very often after the foreign entity leaves, the systems are not being maintained as they should. And maintenance is very important, because if they are not being maintained, they will eventually fall apart. Sensors will go, certain aspects of the telemetry is going to get messed up. You understand? Actuators might get damaged and what have you. And it has to be maintained. 1, 2, very often the kind of training that is needed is not given to the level that is needed. So when the individual or the team from the foreign entity leaves, the utility is left with something that they don't know much about. And I'm not sure why, when these projects are done, training, I think, should be a bigger part of the implementation of the project, so that when the foreign entity leaves, the local utility can both maintain, extend, or expand, and do anything that needs to be done in terms of the system that has been put in place.
Yeah.
And that's a problem that we have in a lot of the islands.
Some of the training
nice
is just
projects.
too trivial.
Urban?
I say some of the training is just too trivial, just a brush and go, and
Yeah.
The operators don't take it serious, and that's why
that's a problem we have.
You have a big difference between training and education. You see, so
yeah,
so you
it's
need
a
both.
big problem, a major problem in my opinion.
Yeah.
Ezekiel said that's what's happening in Dominica now.
Already, and they shouldn't be. You should be getting new equipment from sensitive disasters and so on and so forth. I suppose the speed in which it was done, the expediency, how much of the knowledge was passed on, how much training,
very,
how much
very
education,
important.
how much, that's the problem we always be. And then we have COVID-19 now, and then the hurricane season going to stare us in the face in no time.
Yeah, boy, that's
again.
Two major challenges that we have to face together.
We in this part of the world is not easy. Yeah.
Those two major challenges. I'm just hoping that
Yeah.
the hurricane season give us a
God will
little
smile
ease
at
up.
us this time.
Yeah, I just hoping we get a little ease up, you know, because to have to deal with the additional damages from hurricanes with the already impending economical impact of this COVID-19 stuff, that would be a, boy, a mess. So I don't know if we have additional questions. But if we do, I would like to take them now. Questions, discussion, failing that, I'm guessing that if you have questions that you did not ask in the class, you can ask them in the forum or in the WhatsApp group. But I believe we've gone way past our time. Yeah,
But it's
so
good. It's
I
lockdown
will,
time.
I will
I saw it last week. People
bring
are
the
more
class to an
relaxed.
end. So what will happen, the videos from today, as well as those from the previous class, will be posted by this evening. So they will be there by tonight. I am going to open up the next week for you to start going through it. Some of you have not gone through the content that we went through today, so I advise you to go through it as well. Also, I want to remind those who have not done the last worksheet. At the start of the class, Alphonsus mentioned it.
Yep.
But those who have not done the last worksheet, I want to remind you to do it and upload it so that
We'll
we
do
can
some
take a look at it
corrections.
and give you feedback. Okay, so thanks for your time. I
All the
hope that
best.
you have an enjoyable day. Well, enjoy the rest of your Saturday. Even if for some of us, we are locked in, but you can still
Yep.
enjoy yourself even if you're locked in.
Yep.
Okay, so all the best. I
Think
want to
about
thank
Nelson
everyone again.
Mandela was locked in for 27 years, eh?
Yeah,
And he
boy.
didn't have any phone. He couldn't see anybody. And all he was doing was breaking stones. But the only thing that kept him alive was a vision. So don't get too worried. We still good. We home, but we have phone. We have access.